Now, we took a look at, now this picture I got right out of your book. We'll go back to the other one. This picture I got right out of your book. Here's two linear equations. They cross at this one point. Sometimes the lines might not cross at all. If the lines don't cross at all, what are they? They're parallel lines. Parallel lines have no solution. Now, these are not parallel, obviously. They cross at one point. Therefore, they have one solution. They have one intersection points. Okay? Lines, the linear equations can also have many solutions, and that's if they're the same line, because they lay on top of each other. Okay, but here, this one right here, we have a quadratic right here. And the line runs into 2 points. So when we solve a quadratic, a system with a quadratic, we're going to get how many answers? We're going to get 2 answers. This one has 2 right here. Now, sometimes this might happen. The line never even intersects the quadratic. If this happens, when you're solving it algebraically, you'll get something like a complex number. You'll have an I in there. And if you have an I in there, then you know that the graph looks something like this, and you have no solution. So, let's look at an example. Hopefully this works out pretty. We don't have to use a quadratic formula, but sometimes you do have to use a quadratic formula. Now what you want to do here is you always want to start with the linear equation and solve for one of those variables. You could technically solve for one of these variables, but oh wow, actually it wouldn't be that bad. Actually, okay. I'll let you guys choose. Which variable would you guys like to solve for?
Bottom one.
Let's number them. We have 1, 2, 3, 4, or 5. Which one do you want to solve for?
5.
Okay, 5 is not a bad idea. That's the one I did with my other class. I would do 5 or I would do 3. If I solve for that one, then you just take whatever you get and plug it into this y right here. But maybe I'll do that in this video. Well, let's just solve for this one first. Okay, so look at that y alone. So we have 2x minus y equals -1. So I subtract 2x from both sides to get -1 minus 2x. And then how do I get make this a positive 1 right here? Divide by -1. Peace out. Now you're a positive 1y. You divide both of these by -1, so you get positive 1 and you get positive 2x. Now the y is alone. Okay, leave. All right. Now we're using this guy. So the y is alone. So I'm going to take this and plug it into that y. So what's this going to look like? Oh, it's going to look a little gnarly, but let's see. Oh, we got x squared plus 4x minus y equals 7. And I give a lot of space for my y because now it's 1 plus 2x. Now, can I just get rid of these parentheses? No. You have to do something with the -1 that's chilling right in front of it. So you distribute the -1, so now you have x squared plus 4x minus 1 minus 2x equals 7. So I just went -1 times +1, and then I went -1 times +2, and that's how I got these 2 answers right here. Now I need to simplify. So let's see. Let's combine this guy and this guy because they both have an x term. X squared plus 2x minus 1 equals 7. Alright, here's our quadratic equation. Now, is this quadratic equation in standard form right now? Nope. What does it have to equal in order for us to be able to solve it? It has to equal 0. So let's get rid of this 7 right here by subtracting it. We got x squared plus 2x minus 8 equals 0. Now, we can use the 0 property, we can use the quadratic formula, we can use square roots. There's a bunch of different ways to solve this guy. I'm hoping that I can use the 0 property, so I'm hoping that I can factor this. Is it factorable?
No.
Let me see. It has to multiply to get -8, and it has to add to get +2. Yes, it works. We have x plus 4 and x minus 2. -2 and +4. And I can go straight to my factors because I have a leading coefficient of 1. So I don't have to use grouping or anything like that. So what are my 2 x values? -4 and dose. So I have 2 points where they intersect at -4 and 2. I just have to find the y's for each of these. Now how will I find the y's? Plug them in. You can plug it into this one right here, this top one, or you can plug it into this nice pretty one right here. Let's do the nice pretty one. Okay, so I plug in, let's see, we go y equals 1 plus 2 times negative 4. That'll be negative 8. Add the 1. What do we get? Negative 7. Right? Am I good? Okay, then we have the other one. Y equals, I'm just copying this guy right here. Y equals 1 plus 2 times 2. No, not negative 2, just 2. Okay, I just got this 2 right here and plugged it in. Okay, and then we get 4 right here. Add the 1, we get 5. So these are your two solutions for this system.
Does it matter which one you...
Okay, so how would we do it the other way? How would we solve for this y right here? Well, it's not that difficult. I mean, like, let's see, x squared plus 4x minus y equals 7. Let's move the y over to this side so then it's positive. So let's see, we'll add y to both sides. So that's gone right there, and I add y to this side. So now I have x squared plus 4x equals 7 plus y. Now how would I get rid of the 7? Yeah, you just subtract 7. So subtract 7. So now I have x squared plus 4x minus 7 equals y. Now this y is alone. So I don't need this guy anymore. So I would take this guy right here and plug it into this y right here. And if you did that, you would find the y values. And once you find the y values, you have to plug the y values in. No, wait. No, I would find x values. Oh, yeah, I would find x values. So I plug this into this, then I'd solve for x, and you'll get the same x values as what we did before. So there's two ways to do it. Do the first way, do the second way. Don't matter to me. Whatever is easiest for the problem that you're looking at, because sometimes you can't do it exactly. Actually, most of the times you can't do it exactly the way I do it. You got to try to understand it. All right? All right.